How's it, grade 12? So now what we're going to do is we're going to work out the equilibrium point of this population, okay? And what we can do is we can read it off the phase plot over here, which is going to be that point over there. But the problem with that is we're going to get like round off error kind of thing, because we can't read that off exactly. So the best way to find it is using algebra, okay? And if you remember a few weeks back, I spoke about the equilibrium point or the stable point, and that happens when you have Rn plus 1 equals Rn, and the other one, so that's for your prey, and then for the predator, it's Fn plus 1 equals Fn. That is when your equilibrium or your stable point will happen, okay? So if we look at the previous example that we just did, I'm going to model both of the tigers and the deer with their recursive formulas, okay? And this is coming from the predator-prey video that I did, okay? So we've got our two formulas, which are, and I'm going to write it in terms of deer and tigers. So just remember that R is rabbit, so that is your prey. So for the prey recursive formula, we're going to use this formula here. And I'm just changing the R's to a D, okay, just for deer. So we get dn plus 1 equals dn plus a times dn into 1 minus dn over k minus b times dn times, and f is now going to be your tigers, so I'm going to call that tn. Okay, so this will be on your formula sheet, but it'll be in terms of R and F, but you can just adapt it to whatever they're asking, okay? So now what I'm going to do is I'm just going to put in some values here, so we know what's going on. So this D here is going to become dn plus 1 is equal to dn plus, now this we know from the previous example, they told us that your A is 0.19, and then we have dn one minus dn, your carrying capacity 1200, minus the depth, the B is 0,007, and we have dntn. Okay, so that's for our prey. If we look at the predator, and I'm going to use the formula of our formula sheet, which is, now I'm just going to adapt it to tigers. So we get tn plus 1 equals tn plus f times b times dn tn minus c times tn, okay? And if I just put my values in, I'm going to get tn plus 1 is equal to tn plus 0,123,491 dntn minus 0,009 times tn. Now, grade 12s, this is how these type of modeling questions happen. There might be a lead up to this, and you might have to find things like your A and your carrying capacity and your B. In this case, this whole number here is your F times your B and your C value and stuff like that. Okay, so just go through that previous example that I posted on Teams, and it'll show you how you can find these values. It's a simple case of just plugging it into the formula and then just solving. Okay, so how are we going to use these two here? So we're looking at this one and we're looking at this one to find our equilibrium point. So how this works is to find the equilibrium point for the prey, you're going to use the predator one. Okay, so we're going to use this one to find the prey's equilibrium point. Then we're going to use the prey one to find the predator one. Okay, so I'm going to start it off here and I'm going to work with the predator one first to find the prey. Okay, so we know that for the predator, Fn plus 1 must be equal to Fn for an equilibrium point. Okay, so that means that Tn plus 1 will become Tn. So this becomes Tn is equal to Tn plus 0,00091 dn times Tn minus 0,009 Tn. Now, why are we making Tn plus 1 equal to Tn? Because that means that there is no growth, okay? The population has hit its equilibrium point. It's neither increasing nor decreasing, okay? So if I take this Tn and this Tn will cancel, and we left with 0 is equal to 0,91 dn times Tn minus 0,009 Tn, okay? And if I take this one to this side, it becomes a positive, and I get 0,009 Tn is equal to dn times Tn. Now what I can do is I can divide through by Tn to cancel the Tn's, and we left with 0,009 equals 0, times dn. Then I can just divide through by this number, and I can get that dn is equal to, now it's going to be approximate, okay? So if we have a look on the calculator, we're going to get 0,009 divided by 0, and we're getting that. So I'm just going to round it up because it's approximate, so we get 99. Okay, so that means that the prey equilibrium point is 99 deer. Okay, if we look now at the solving for the predator one, we're going to use the prey model. Okay, and that was dn plus 1 equals dn plus 0,19 dn into 1 minus dn over 1200 minus b times dn/tn. Okay, so so I didn't put in my b value, I'll put in that now. But for equilibrium, we know that dn plus 1 must be equal to dn. So this dn is going to become dn. So we get dn is equal to dn plus 0,19 dn 1 minus dn over 1200 minus 0,007 dn times tn. Okie doke, so this will cancel, and we are left with 0 is equal to 0,19 dn into 1 minus dn over 1200 minus 0,007 dn/tn. Okay, so what I'm going to do now is I'm going to take this -1 to this side here, and we get 0,007 dn times tn equals 0,19 dn 1 minus dn over 1200. Okay, I'm going to divide both sides by dn, and we are left with 0,007 tn equals 0,19. Okay, so that's cancelled, and we are left with 1 minus dn over 1200. Okay, now we have a bit of a problem because we have this dn over here, but we solved for dn in the previous one, okay, and we solved it to be 99. So this becomes 0,007 tn is equal to 0,19, 1 minus 99 over 1200. Okay, and if we just do this on the calculator, we take that divided by that. Let's have a look at what that gives us. So we've got 0,19, 1 minus 99 over 1200. Okay, and we divide that by 0,007, and we are getting approximately 25. So Tn is approximately 25. So therefore there are 25 tigers. Okay, so let's go through the process again, grade 12s. For an equilibrium point, Rn plus 1 must be equal to Rn. Fn plus 1 must be equal to Fn. Build up your model, okay, like we did here. Then you're always going to solve for the predator 1 first. Solve for the predator 1 to get your prey. Once you've got your prey, you can use your prey model to solve for the predator, and you're going to use your value that you got here for your prey, in this one over here. Okay, to get rid of that. And that is how you solve your equilibrium points or your stable points algebraically.